So in today's lesson, we are going to learn about modulus and argument. So modulus of a complex number z is the distance from the origin, right? So if you are taking 2 plus 3i, its distance from the origin, how much it should be? So it is 0. You go here 1 here and 2 here, 2 on the real part, and imaginary part will be 3. So it should be 1 and 2 and 3. Okay, and if you just draw this, so this will be your complex number z, which is equal to 2 plus 3i. Okay, now it is showing distance from the origin to that number, so this will be your modulus of z, right? This is your modulus of z, distance of z point from the origin O. So how we can find it? So you know that it is 2 and it is 3i, right? So I is just representing, it is on the imaginary part. So if we use Pythagoras theorem in this triangle, so modulus of z, you can say it should be 2 square and plus 3 square with a square root sign. So it should be 4 and it should be 9 and it should be root 13, right? So modulus is root 13. So for any complex number z equal to x plus iy, the modulus is modulus of z equal to x square plus y square. That should be the rule. Okay. Next one is the argument. Argument of a complex number is the angle its corresponding vector makes with the positive real axis. So what does it mean? If z is a complex number, so angle between the positive real axis. So see here, please note, it is positive real axis and the line joining that number to the origin. So like I have taken the example of 2 plus 3i, right? 2 plus 3i. So this is 2 here and this is 1, 2 and 3 here. So this will be 2 plus 3i, right? This will be 2 plus 3i. So this angle theta means angle between the line and the positive real axis. So this is positive real axis, yeah, is given by theta. So this angle theta is called argument, right? This is called argument of a complex number, right? And how it is going to be given? So if z equal to, it is x plus iy, so we know that this distance is x and this distance is y. So we can say argument tan theta, that is using SOHCAHTOA, so it should be y over x. So theta is given by tan inverse y over x, yeah. So this theta is argument. Okay, is that fine? So let's see one more example. So let's take z equal to 2 plus 7i, yeah. So this is our question, z equal to 2 plus 7i. So we need to find the argument. So z equal to 2 plus 7i, if you compare it with x plus iy, okay, so your x will be 2 and your y will be 7, right? And if you need to find argument, so we know that tan theta equal to y over x. We have just found here. So if you see tan theta equal to y over x. So what is y value here? 7. And what is x value here? 2. So theta equal to tan inverse 7 over 2. So put this value in a calculator. So you will get theta, that is 1.2924 radian. Okay, so your calculator should be on a radian mode. So it is theta equal to 1.2924 radian, or you can say up to 2 decimal point, that is 1.29 up to 2 dp. Okay, so if this is all about when z is lying in the first positive quadrant, means if this is the quadrant, this is positive quadrant. If z is lying in this quadrant, then we are going to use this rule. What happens if z is lying in a different quadrant? So see here, so if in a different quadrant, so let's see this diagram now. So if z does not lie in the first quadrant, you can use the Argand diagram to help you find its argument, right? So if this is angle alpha, it is in the first quadrant, right? So you can say if z lies in the first quadrant, then argument z will be alpha, right? Okay, if Z lies in the second quadrant, so this is your first quadrant and this is your second quadrant. So then this angle will be Z equal to pi minus alpha. Why it is pi minus alpha? If you measure it from here, you can see my red ink and it is stopping here. So this angle is pi minus alpha, right? Okay, above real axis it is positive and below real axis it is negative. In what way it is negative? I'll explain you here. If Z lies in the third quadrant, so this is third quadrant, okay, so then you are going in this direction. So if you see my blue ink, blue ink, so see here, you are going until here and you are stopping here. So how much is this angle is? This is pi minus alpha, but because it is in the negative direction, so we'll put minus pi minus alpha. Okay, if it is in the fourth quadrant, then you are measuring this angle only, and because it is in the negative direction, then it will be minus alpha. Is that okay? So for first quadrant, it's Z equal to alpha. For second quadrant, that is this one, that is Z equal to pi minus alpha. For third quadrant, that is this one, Z equal to minus pi minus alpha. And for the fourth quadrant, it is Z equal to minus alpha. Is that clear? Okay. So here's a question. If Z is minus 4 minus I, you need to find the modulus of Z and argument of Z. So for modulus of Z, what you are going to do? Modulus of Z is square root minus 4 square, then plus sign in the middle, and it should be minus 1 square. So minus 4 square will be 16 and it should be plus 1, and modulus will be square root 17. Okay. Now that is your I part. Now II, here they are asking you need to find argument of Z. Okay, so if you draw this minus 4 minus I, so see in which quadrant it is. Okay, so minus 4, let's draw here 0. This is minus 1, minus 2, minus 3, minus 4. So minus 4 here, so we have taken, and minus 1 is down, right? So suppose this is minus 1. So this will be the point. Yeah, so this is your modulus Z, right? So this is your first quadrant, this is your second quadrant, and this is your third quadrant, and this is fourth quadrant, right? So our complex number Z is sitting in third quadrant, right? Yeah, so once it is in the third quadrant, if you see here what we have done, that its argument Z is given by minus pi minus alpha, isn't it? So it should be minus pi minus alpha. So what you can do, you can just measure this angle. Okay, so and let's this angle is alpha. So if it is minus 4, so we are just writing here minus 4 and this is 1. So 10 alpha we can find it. So when you are finding 10 alpha, guys, so remember, don't put minus 4 because we are already taking into consideration it is negative. So 10 alpha is 1 over 4, like TOA, opposite, over adjacent. So 1 over 4, right? And once you find on a degree, so on a radian mode, so alpha equal to 10 inverse 1 over 4. And if you put value in the calculator, so it should be alpha is 0.2449. Okay, is that fine? So what should be the, so this angle is, I'm just putting with the red ink, just see here, this angle, this red angle, we got it 0. Alpha is 0.2449. Okay, this angle is, so what should be the argument Z? So this red angle, so this is pi minus alpha and with minus sign. So minus sign, pi, and alpha value is 0.2449. If you put this value in a calculator on a radian mode, pi minus 0.2449, it will be coming minus 2.90. Okay. So here's a question. For each of the following complex number, find the modulus, writing your answer in the third form if necessary, and find the argument. So you need to find the modulus and the argument. So modulus of Z, immediately you can find it, is square root minus 4 square, and it should be 11 square. So minus 4 square will be 16. 11 square is 121. And if you add it, it should be 137. Okay. And if you are going to find argument z, so let's draw it. So minus 4 plus 11i, minus 4 will be here. Okay, this is your minus 4 and 11 will be here. So this should be point here, minus 4 plus 11i. So your vector is here. So angle made with the real axis, so that is your alpha. So alpha we can find it. So this is 11 and this is 4. Don't put minus sign here. So tan alpha equal to 11 over 4. And if you put in a calculator, so alpha equal to tan inverse 11 over 4. And if you put this value, so I can get here 1.22 something, right? 1.22. Now, for this part, what should be the argument z? Argument z will be pi minus alpha, because we are in the second quadrant. So if you go for the second quadrant, you can see here argument z will be pi minus alpha, isn't it, right? So let's go back and we can write down here argument z is pi minus alpha. So it should be pi and alpha is 1.22 and you can simplify. So it should be 1.92 radian. Okay. Now next question is 2 root 3 minus I root 3. So let's find the modulus of z. Modulus of z is square root 2 root 3 square. Okay, so it should be 2 root 3 square and it should be minus root 3 square. Okay, so 2 root 3 square, it should be 4 and it should be 3 and it should be 4 times 3 becomes 12 and it should be 3. Yeah, so it should be 12 plus 3, it will be 15, right? Now, to find the argument of z, where it should be 2 root 3. So if you see here, 2 root 3 will be here and then minus I root 3 will be here. So it should be like this, isn't it? So it is 2 root 3 and it is root 3 and we need to find alpha here. So tan alpha equal to root 3 over 2 root 3. Okay, and if you simplify it, you are getting 1 by 2, right? Okay, what should be the argument z here? This is first quadrant, second quadrant, third quadrant and fourth quadrant. So fourth quadrant argument z will be given by it is minus alpha, right? It is minus alpha. So let's put it here. So it should be minus alpha. So how much it should be? Minus 0, 1 by 2 and alpha you will find it. It should be 0.46. So argument will be minus 0.46. That is your argument z. That is minus 0.46. Okay. Here's an exam question. Z is given 3 plus 4i and you need to show that z square equal to minus 7 plus 2i. So z square, okay, so z square means you are multiplying z times z, right? And what is z? Z is 3 plus 4i here and you are multiplying 3 plus 4i. Okay, so once you multiply this, so it should be 3 plus 12i and it should be 12i and it should be 16i square, right? So it should be 9 plus 24i and 16i square becomes minus 16. So we got minus 7 plus 24i. That is your show that z square is minus 7 plus 24i, that we have already shown. Now they are asking, this is your A part. Then they are asking what is modulus of z square. Modulus of z square is minus 7 square, okay, and plus 24 square. So minus 7 square is 49 and 24 square is 576 and if you add it, so it should be square root 625 and that is 25. Okay. Now then they are saying C part, argument z square giving your answer to 2 decimal place. So this is detail they want. So argument z square. So our z square is minus 7 plus 24i. So let's see in which quadrant it is. So minus 7 should be here. Okay. And plus 24i. So it should be here. Is that fine? Yeah. So it is your 7. Don't put minus 7 because we have already taken in the negative direction, and it is 24, and we can find alpha. So 10 alpha is 24 over 7. Alpha equal to 10 inverse 24 over 7. So 10 inverse 24 over 7, which comes, it is 1.287 something. Yeah. Okay, because it is in the second quadrant, first quadrant, and it is in the second quadrant. Second quadrant, argument of z square will be given by pi minus alpha. And what is alpha? Alpha is 1.287. From calculator, if you minus it, pi minus 1.287, so it should be 1.85. Okay. Now, last part, so A done, B done, C done, and D. Show that Z and Z square on the Venn diagram. So our Z value is 3 plus 4i. So 3 plus 4i, you can show it. So this is your 1, 2, and 3, and 4i. Let's take 1, 2, 3, and 4. So it should be somewhere here. That should be your Z. 3 plus 4i. Okay. And then they are showing Z square. So our Z square is minus 7 plus 24i. So minus 7, suppose on this line. Okay. Minus 7 will be here. So suppose this is minus 7, and 24i will be somewhere here up, right? And you can join them. So let me change the ink so that it should be clear now. So this is your z, and this is your z square, right? So z square, and it is z. So then you can do it, right? Z square and z. Is that okay? So this should be your Aragon diagram they want to see on the paper. Is that okay? So this is another exam question, and here it is given z equal to minus 1 minus I root 3 and find modulus of z. So modulus of z, you can find it simply equal to square root minus 1 square. Okay. And it should be minus root 3 square. Okay. Root 3 square. So it should be 1 plus 3, and that is root 4. Root 4 is 2, right? Now, this is your A part. B part, they are saying modulus of z divided by its conjugate, right? This is given. So if z is minus 1 minus I root 3, okay, and conjugate will be minus 1 plus I root 3. Is that okay? So this is value of z over z conjugate, right? And this is what we need to find. This is nothing. Yeah. So this is what we have done. So we need to rationalize it. Rationalize it, just put it in a bracket and then change the sign and multiply in the numerator and denominator. Okay. So it should be minus 1 minus I root 3. Okay. And it is minus 1 plus I root 3. And it should be minus 1 minus I root 3. And this is minus 1 and minus I root 3. Okay, this should be z over conjugate of z, right? So if you multiply, so it should be minus 1 times minus 1 becomes 1. Minus 1 times minus, if you multiply, so it should be plus I root 3. Okay. Now you are multiplying with this other part, like this one, minus I root 3 times minus 1, it should be again I root 3, and minus I root 3, if you multiply, minus and minus becomes plus, and it should be I square. Root 3 becomes 3, so it should be 3I square. Okay. Now divided by, when you multiply this, minus 1 times minus 1, it should be plus 1. Minus 1, if you multiply here, it should be plus I root 3. Okay. Now we are going to do other part, that is this one. So plus I root 3, if you multiply, it should be minus I root 3, and plus I root 3 if you multiply with this, so plus and minus becomes minus, and it should be I square. Root 3 times root 3 becomes 3. Okay, so this minus I root 3 plus I root 3 will be cancelled. Okay, so it should be 1 plus this I root 3, and I root 3 becomes 2I root 3, and 3I square becomes minus 3. Okay, and here you got 1. I square is minus 1, so minus 3, and it is minus 1. So in the denominator it should be 4. Okay, and 1 minus 3 becomes minus 2, and it should be 2I root 3. Is that okay? So this is what we got it. Now if you simplify further, so this you can write down z over z conjugate, that is minus 2 over 4, and it should be plus 2 root 3 I over 4. You can simplify, so it should be minus 1 over 2, and it should be 1 over 2 root 3 I. Is that fine? So this is your z over z conjugate. Now they are asking modulus of z over z conjugate. Okay, so it should be square root minus 1 by 2 square plus 1 by 2 root 3 square. So it should be 1 over 4 plus 1 over 4, and root 3 square, it should be 3 over 4. So it should be 4 over 4. Answer will be 1. So this is end of B part. Then they are saying C part, argument Z, argument conjugate Z, and argument Z and Z conjugate, giving your answer in terms of pi. So we need to find everything in terms of pi. So what should be your value? So first of all, your argument Z. Okay, so what was the Z value? Z value was, if we see here, Z value was minus 1 minus I root 3. So let's write down here minus 1 minus I root 3. Okay, so what should be the argument Z here? What should be the argument Z here? So if you plot it, so minus 1 will be here. Okay, and minus I root 3 will be here. So we are in the third quadrant. So if this is alpha, okay, and this is 1, and this is root 3. Okay, root 3. So 10 alpha equal to root 3 over 1, and it means alpha equal to 10 inverse root 3 over 1. So once you put this value in a calculator, so you can say it is pi over 3, right? Then we are in the second quadrant. First quadrant. This is second quadrant, and this is third quadrant. So we are in the third quadrant. So third quadrant, it should be minus pi minus alpha. Minus pi minus alpha. This will be your quadrant. So it is minus pi minus alpha. Alpha is pi over 3. And you can simplify. So 3 pi minus pi, that is 2 pi over 3. So it should be minus 2 pi over 3. Is that okay? Yeah. Too much calculation. That is your first part we have done. Then they are saying argument of conjugate Z. So argument of conjugate Z here. So what is argument of conjugate Z? It should be again same. It should be 10 alpha equal to root 3 over 1. Okay, and alpha will be 10 inverse root 3 over 1, and this value again pi over 3. Okay, but where it will be? It should be in which quadrant? Argument Z conjugate. It's where it should be. It is in the second quadrant, right? It is in the second quadrant, so it should be pi minus alpha, isn't it? So it should be pi minus alpha, that is pi by 3. So it should be 2 pi over 3. Okay, and the last one is argument Z over Z conjugate. Yeah, so Z over Z conjugate, we got this one. If you see, minus 1 by, this is what we got, minus 1 by 2 plus 1 by 2 root 3. Yeah, so this should be minus 1 by 2. Okay, and positive 1 by 2 root 3. So it should be, so we will be in the second quadrant, right? Second quadrant will be pi minus alpha. So let's find alpha first. So tan alpha equal to, so we can divide this root 3 by 2i, that is root 3 by 2 divided by 1 by 2. Do not put minus sign. So it should be 2 and 2 cancelled out. So we'll get root 3. Okay. So alpha equal to tan inverse root 3. It should be pi over 3 again. Okay. Now it is in the second quadrant. It is in the second quadrant. So second quadrant will be argument pi minus alpha, isn't it? Pi minus alpha. So pi alpha is pi over 3. And if you simplify, it should be 2 pi over 3. Is that okay? So remember, when you are finding argument z, so we are going to use these rules. Yeah. And this is going to be very, very important for you. Okay. So I hope this is clear. Yeah. And if you have any doubt, you can always ask and comment. Bye-bye.